close your eyes. Breathe slowly in. Let your body sink deeper into the surface beneath you. Feel the weight leaving your shoulders, your arms, your legs. Tonight, we're going somewhere special. Imagine you're lying outside on a clear night. The air is cool and still. Above you, the sky stretches endlessly. At first, you see just a few bright stars. Then more appear, and more, until the whole sky is filled with tiny points of light. And then you notice something else, a faint band of light stretching across the darkness, like a river made of stars. Soft, glowing, ancient. That is the Milky Way, our own galaxy. That hazy band of light you sometimes see in the sky, that is us. We are inside it. Every star you've ever seen, every planet, the sun, the moon, they all belong to the Milky Way. Tonight, we're going to travel through it together. Not with a spaceship, but with words and imagination. In the coming minutes, you'll hear 100 facts about our galaxy, told calmly, described clearly, so you don't just learn, but truly see it before you. You don't need to remember anything. You don't need to understand anything. Just let the words drift past you like starlight through space. Breathe calmly and let yourself be carried away. The Milky Way contains somewhere between 200 and 400 billion stars. 200 billion. Try to picture that number. You can't really, can you? More stars than grains of sand on a beach. More than all the trees on Earth. And each of those stars is a sun just like ours. Many of them with their own planets, their own story. That hazy band of light we sometimes see in the night sky, that is the Milky Way itself. We're looking from the inside toward the rest of our galaxy, like standing inside a huge wheel and looking around and seeing all the other spokes, all the other stars surrounding you. From a dark place on Earth, you can see it, like a soft, milky river through the air. That's why we call it the Milky Way. At the center of the Milky Way sits a super heavy black hole. It's called Sagittarius A star, and it weighs 4 million times as much as our Sun. But don't worry, we're far enough away to be safe. The black hole holds the center of the Milky Way together, just as the Sun holds our solar system together. It is the heart that holds our galaxy together, silent in the darkness, but always at work. Our solar system doesn't sit in the middle of the Milky Way, but on the edge of a spiral arm, the Orion Arm. We're floating in a quiet neighborhood of the galaxy, far from the busy, hot center, far from the huge gas clouds and young, explosive stars. Here it is calm, stable, safe enough for life to begin. A perfect place to call home. The Milky Way is a barred spiral galaxy, not a regular spiral. That means a kind of bar runs through the middle, a stretched out collection of stars. From that bar, 4 large spiral arms wind outward like a spinning pinwheel of light. If you could see the Milky Way from above, you would recognize that beautiful spiral shape, a structure that formed millions of years ago and still slowly turns. Those spiral arms are filled with gas, dust, and young stars. They are the nurseries of the Milky Way, places where new stars are born. Between the arms it's quieter, darker, less active. But in the arms themselves, that's where it happens. Huge gas clouds spark together and new suns appear. Our solar system also sits in such an arm, the Orion arm. Between the spiral arms sit dark regions where fewer stars are. Those regions aren't truly empty. Old stars, gas and dust still float there. But it's quieter there, colder, less new life. If you could travel through the Milky Way, you would feel the difference, from the busy, bright arms to the silent zones between them. A balance between bright light and deep, silent spaces. The Milky Way isn't flat. It's slightly bent, like a curved disc. This bend was caused by other galaxies, their gravity pulling at our disk as they moved through space millions of years ago. Imagine a vinyl record that's been bent slightly. That's how the Milky Way moves too, not completely straight, but with a gentle wave motion. This warping isn't static. It slowly changes over time. The Milky Way reshaping itself as it travels through the universe. Always moving, always transforming. Around the Milky Way sits a huge halo of dark matter. We cannot see that matter, but we know it's there, because without it, the galaxy would behave differently. That halo reaches out far beyond the visible stars. It wraps around our galaxy like an invisible embrace. Without it, the outer stars would spin away into the void, lost forever. In the Milky Way, new stars are born every day. Not just 1 or 2, dozens per year. In huge gas clouds, dust comes together, gets squeezed by gravity, and begins to glow. And then, a new star. It's happening somewhere in the Milky Way, right now, while you're lying here listening. Stars are born in huge clouds of gas and dust. Those clouds are called nebulae. Imagine a cloud so big that light takes thousands of years to travel through it. Inside that cloud, small clumps of matter pull toward each other. They become denser, hotter, until suddenly there comes a moment when the core begins to burn. And then a new star shines through the universe. A young star is surrounded by a disk of material, the birthplace of planets. That dust and gas, left over after the star's birth, spins around it in a flat disk. Slowly, those particles clump together. First, small rocks, then bigger chunks, and eventually, planets. That's how our solar system formed too, billions of years ago. Every star system has such a story. Older stars change. Some swell up into red giants. When a star gets older and the fuel in its core runs out, it becomes bigger, redder, cooler on the outside. Our own sun will do that someday, in billions of years. It will swell beyond Earth's orbit. But don't worry, we'll be long gone by then. When heavy stars die, they explode as supernovas. A supernova is so bright that it temporarily shines brighter than an entire galaxy. In that explosion, all the elements the star ever made are thrown into space. Gold, iron, carbon, everything we know. That explosion isn't an end. It's a beginning. Because from those remains, new stars appear, new planets, new life. After a supernova, sometimes a neutron star remains, extremely compact. Imagine a star as heavy as the sun, but squeezed into a ball the size of a city. So dense that a teaspoon of that material would weigh as much as a mountain. Neutron stars are the most extreme objects in the universe, except for black holes. They sometimes spin hundreds of times per second, a silent spinning top in the emptiness of space. Other stars end as black holes, which swallow even light. If a star is heavy enough, even a neutron star cannot hold. Gravity becomes so strong that everything gets pulled inward, even light. What remains is a black hole, a place where the laws of time and space themselves bend. They're invisible, but we know where they are, by what they do to the stars around them. Some old stars become white dwarfs, small, hot remains. Not every star ends with an explosion. Stars like our Sun die more peacefully. They push off their outer layers and leave behind a glowing core. That core is a white dwarf, small but burning hot. It fades slowly over billions of years, until it eventually becomes cold and dark. In the Milky Way, billions of these remains float through space. Neutron stars, black holes, white dwarfs, everywhere. Silent witnesses to stars that once shone and are now gone. They trace their paths through the universe, invisible but present. The Milky Way is not only a place of birth, but also of memory. The elements in our bodies were once created in such stars. The iron in your blood, the carbon in your bones, the oxygen you breathe. Everything was made in the hearts of stars that lived and died billions of years ago. You are literally made of stardust. And when you look up at the sky at night, you're looking at your origin. The Sun is an average star in terms of size and temperature. Not too big, not too small, not too hot, not too cold. In the Milky Way, there are stars 1,000 times bigger and stars 10 times smaller. But our Sun is just right for us, stable enough to shine for billions of years. And because of that, life on Earth could begin. It's located about 26,000 light-years from the galactic center. 26,000 light-years. Even if we traveled at the speed of light, it would take 26,000 years to reach the center. We're far enough to be safe from the chaos at the heart of the Milky Way, but close enough to still be part of the whole. The Sun orbits the center of the Milky Way in 230 million years. One orbit, 230 million years. The last time our Sun completed such an orbit, dinosaurs walked the Earth. Now we're halfway through again. And in 230 million years, the Sun will be back in the same place. But Earth may look very different. While it orbits, it also moves up and down through the galactic plane. The Sun doesn't move in a perfect circle. It also goes up and down, like a horse on a carousel. Every 30 million years, it crosses the flat plane of the Milky Way. Then it moves through denser regions with more gas and dust. It's a rhythm that's continued for billions of years, a cosmic dance. Our solar system, therefore, moves in a kind of wave pattern through space. We don't just go around, we also go up and down. And as we move, the Milky Way itself also moves. It rotates. It heads toward other galaxies. Everything is in motion. Nothing stands still. And yet we don't feel it because we move along together with everything we know. Scientists estimate there are more planets than stars in the Milky Way. More planets than stars. That means there are probably hundreds of billions of planets. Some large, some small, some warm, some cold. And somewhere among them, perhaps life. Many of those planets orbit other stars, so-called exoplanets. Exoplanets are planets outside our solar system. We can't see them with the naked eye, but we know they're there. Every time a planet passes in front of its star, that star's light dims just a tiny bit. That's how we find them, one by one. There are planets of rock, gas, ice, and even metal. Some planets are huge gas balls bigger than Jupiter. Others are rocky, like Earth, or frozen with oceans of ice. There are even planets that orbit so close to their stars that they have melted metal on their surface. Every planet is different. Each has its own story. Some exoplanets sit in the habitable zone, where water can exist. The habitable zone, the place where a planet isn't too close to its star and not too far. Just right, so water can be liquid. And where there's water, life can begin. How many such planets are there? We don't know exactly, but probably millions. So far, thousands of exoplanets have been discovered, and the number still grows every month. Every month we discover new worlds. Some look like Earth, others are completely strange. And each discovery brings us closer to the question, are we alone? Or is there someone else out there, somewhere in the Milky Way, looking at the stars? The Horsehead Nebula is a well-known star-forming region in our Milky Way. Imagine a huge cloud of dark dust that looks like a horse's head. Behind that cloud, young stars glow, newly born. The Horsehead Nebula is about 1,500 light-years away from us, and yet we can see it, a shadow against the light of new stars. The pillars of creation show stars being born in a nebula. These are perhaps the most famous images of the universe. 3 huge pillars of gas and dust, kilometers tall, where new stars are forming. They stand in the Eagle Nebula, about 7,000 light-years from here. Hubble telescope images show how beautiful and wild the universe can be. The Crab Nebula is what's left of a supernova seen in the year 1054. In the year 1054, Chinese astronomers saw a new star appear in the sky. It was so bright you could see it during the day. What they saw was a star exploding almost 1,000 years ago. Now there remains a beautiful nebula of gas and energy, the Crab Nebula. The Swan Nebula contains young, newly born stars. The Swan Nebula, or the Omega Nebula, is a huge nursery of stars. It sits about 5,000 light-years away from us. In that nebula, hundreds of young stars glow, less than 1,000,000 years old. They shine bright and blue, the color of youth in the universe. Some of these regions are so big that light takes centuries to travel through them. Those nebulae aren't small. Some are hundreds of light-years wide. If you stood on one side and looked toward the other, you would see light from hundreds of years ago. They are landscapes of time and space, too big to truly understand. The Milky Way rotates at a speed of about 900,000 kilometers per hour. 900,000 kilometers per hour. And yet we feel nothing. No wind, no motion. Everything moves along. The sun, the earth, the other stars. We're all passengers on a huge starship, rotating through space. Despite that speed, we don't feel it because of the enormous scale. Everything is so big, so far away, that motion becomes impossible to notice. Just like in an airplane, you don't feel that you're going 900 kilometers per hour. We float along in silence through the universe. And the Milky Way continues turning, calmly and forever. Stars at the edge move more slowly than those in the middle. The farther you are from the center, the slower you move. That's because of gravity. It's stronger in the middle. Our sun, at the edge, takes 230 million years to orbit. But stars closer to the center do it much faster. The Milky Way also sends out radio and gamma radiation. The Milky Way isn't silent. It sends out waves we can't see, but can measure. Radio waves from gas and dust. Gamma rays from black holes and pulsars. If you listen to that radiation with a radio telescope, you hear the Milky Way singing. Magnetic fields affect the shape and movement of gas in the arms. Space isn't empty. Magnetic fields run through it. Those fields pull gas along, send particles along invisible lines. They help shape the spiral form of the Milky Way. And they protect us too. They keep dangerous radiation outside our solar system. Only 5% of the Milky Way is made of ordinary matter. Everything we can see, stars, planets, gas, dust, is only 5% of the Milky Way. The rest is something else, something we cannot see, but can feel. It's one of the biggest mysteries of science. About 27% is dark matter, invisible but measurable through gravity. Dark matter sends out no light. We cannot see it. But we know it's there because the gravity of the Milky Way doesn't work without extra mass. That mass is dark matter. It's all around us, invisible, silent, but always there. Without dark matter, the Milky Way would fly apart. The stars rotate too fast. The Milky Way spins too quickly. Without extra gravity, the outer stars would fly away. But that doesn't happen because dark matter holds them together. It's like an invisible glue that keeps our galaxy together. The rest of the universe is made of dark energy, which is even more mysterious. Dark energy is different from dark matter. It's a force that makes the universe expand faster. We don't know what it is. We don't know where it comes from. But it's there, and it fills almost 70% of the universe. We still don't know what dark matter exactly is. It's one of the biggest puzzles of science. Scientists around the world are trying to understand it. They build huge detectors deep underground. They search for clues. But so far, dark matter remains a mystery. Perhaps we'll discover it someday, or perhaps it will stay hidden forever. The Milky Way isn't alone. It's part of the local group of galaxies. The local group is a collection of about 50 galaxies, some large, some small, all bound to each other by gravity. We're neighbors in space, connected by invisible threads. The nearest large galaxy is Andromeda. Andromeda is 2.5 million light-years away from us. On a clear night, you can see it, a small, fuzzy spot in the sky. But if you look closely, you see an entire galaxy with 1 trillion stars, just as big as the Milky Way, perhaps even bigger. Andromeda and the Milky Way are slowly moving toward each other, very slowly but surely. They're being pulled toward each other by their shared gravity. Over millions of years, they'll come closer, and eventually, they'll collide. In about 4 billion years, they'll collide and merge. 4 billion years is long, very long. But someday it will happen. Andromeda and the Milky Way will move through each other, their stars mixing. It will be a dance lasting millions of years. That collision won't be a disaster. The distances between stars are too big for actual collisions. Stars won't hit each other. The space between them is so huge that they'll simply glide past each other. But the shape of both galaxies will change. Eventually, they'll merge into one new galaxy that scientists have already named Milkomeda. The Milky Way is more than 13 billion years old. 13 billion years. Almost as old as the universe itself. It formed at a time when the universe was still young, still full of energy and possibilities. And since then, it has been turning, generation after generation of stars. It formed shortly after the Big Bang, from smaller galaxies that merged. The Milky Way wasn't always as it is now. In the beginning, there were only small clumps of stars, small baby galaxies. Slowly, they crashed into each other, merged together, and after billions of years, the Milky Way as we know it appeared. Some old stars in the halo are almost as old as the universe itself. In the halo, the cloud around the Milky Way, old stars drift. They're 13 billion years old, perhaps older. They were already there when the Milky Way had only just formed. When you look at those stars, you look back in time to the beginning of everything. The Milky Way is therefore built from many earlier galaxies. The Milky Way is a mosaic built from the remains of other galaxies that came together long ago. Every star has its own history, each has its own origin, and together they form our home. Our galactic history is literally stored in the light of old stars. When you look at old stars, you see the past. The light now reaching us left thousands, millions of years ago. By studying that light, we can rebuild the history of the Milky Way. We read the past, written in starlight. The Milky Way is constantly changing. Stars die, new ones are born. The Milky Way isn't frozen, it lives. Every day, stars die somewhere, and every day, new ones are born somewhere. It's a cycle that's continued for billions of years, and will continue for billions more. In billions of years, it will merge with Andromeda. We already know. It's certain. In 4 billion years, the Milky Way and Andromeda will come together. They'll dance, spin, move through each other, and then become one. The result will be a new galaxy, Milkomeda. Milkomeda, a name that brings both galaxies together. It will be bigger than the Milky Way, fuller, brighter. Perhaps it will become an elliptical galaxy without spiral arms. A new form, a new beginning. The black hole at the center will become even bigger. When the Milky Way and Andromeda merge, their black holes will merge too. They'll spiral toward each other, slowly, inevitably, and eventually fuse into one huge black hole, the beating heart of Milkomeda. Eventually, the galaxy will fade as the last stars grow dim. Over trillions of years, all stars will have burned out. No more new stars, no more light. The Milky Way, or what remains of it then, will grow dark. But that's so far away, it's almost impossible to imagine. For now, it still shines, and will continue to shine for a long time. Seen from space, the Milky Way looks like a thin disk of light. If you could go far enough away and look back, you would see the Milky Way as a flat disk with a bright bulge in the middle, spirals of light turning outward, a beautiful, fragile thing floating in the void. Our solar system sits in a quiet, stable place. We're not in the busy center, not in a chaotic gas cloud. We're in a quiet neighborhood where it's safe, where stars exist long enough for planets to form, and where life gets a chance. We have exactly the right conditions for life. A rare coincidence. Not too close to the center, not too far away. A stable star, a planet at the right distance. Water, an atmosphere, protection from radiation. It's a combination that's rare, but here on Earth went exactly right. From distant stars, Earth would be invisibly small. If someone elsewhere in the Milky Way were looking at us, they would see the sun, perhaps, if they had a telescope. But Earth, they wouldn't see it. A tiny dot hidden in the light of our star. Yet we, from that small dot, are able to understand the Milky Way. We are so small, so tiny on the scale of the universe, and yet we can measure the Milky Way, understand it, map it. We look at the stars and we understand how they work. From a small dot, we understand the universe. Light from one side of the Milky Way takes 100,000 years to reach the other side. 100,000 years. Light is the fastest thing that exists, and yet it takes that long. That's how big the Milky Way is. An ocean of space, where even light needs time to travel through. When we look at stars, we therefore see them as they were long ago. That star you see shining may no longer be shining. What you see is light that left thousands of years ago. Space is so huge that time slows down. We're not looking at the present, we're looking at the past. Some stars we see no longer exist. They've already died, exploded, faded. But their light is still on its way. It's still traveling through space toward us. And when it arrives, we see a star that's no longer there. Telescopes are actually time machines. They look into the past. The farther we look, the farther back in time we see. When we look at distant galaxies, we see how they looked billions of years ago. We can see the past captured in light. Telescopes are windows into the history of the universe. Light from distant nebulae tells us stories about the youth of the universe. Some nebulae are so far away that their light is billions of years old. What we see is how the universe looked when it was still young, full of energy, full of new stars. The past of the cosmos, still visible in the light. The space between stars isn't empty. There's gas, dust, and energy. Space seems empty, black, silent. But there's always something floating. Hydrogen atoms, small dust particles, radiation traveling through space. It's almost a vacuum, but never completely empty. This interstellar matter forms the raw material for new stars. That gas and dust isn't just cosmic trash. It's the building block of the future. Slowly it clumps together, gets squeezed, begins to glow, and then a new star made from the dust of old stars. In some regions, the dust is so thick that light barely passes through. Some parts of the Milky Way are almost impossible to see through. Dark clouds where no light comes through. If you were there, you'd see nothing, only darkness. But behind those clouds, it's happening. That's where stars are being born. Radio telescopes can look through that dust. Regular telescopes only see light, and that gets blocked by dust. But radio waves pass through. With radio telescopes, we can look at what's happening behind the clouds. We can see what's invisible and discover what was hidden. This way, we discover more and more about the inside of our Milky Way. The center of the Milky Way is covered with dust. We can't see it, but with radio waves, X-rays, and infrared light, we can look through. We discover black holes, young stars, dense gas clouds. Bit by bit, we're revealing the secrets of our galaxy. In the Milky Way are pulsars, spinning neutron stars that send out radio signals. Pulsars are lighthouses in space. They spin rapidly, sometimes hundreds of times per second, and each time they rotate, they send out a flash of radio radiation. Like a lighthouse turning, but in the emptiness of space. Some black holes shoot out jets that reach for light years. Not all black holes are silent. Some eat matter so quickly that they spray energy in huge jets. Those jets reach light years into space. Beams of light and particles so powerful they destroy everything in their path. There are stars that are 1,000 times bigger than the Sun. 1,000 times. If you placed such a star in our solar system, it would reach beyond Jupiter's orbit. Huge balls of gas, so big they are almost impossible to imagine. And they burn brightly, but briefly, because the bigger a star, the faster it dies. Others burn millions of times brighter. Some stars simply shine millions of times brighter than our Sun. They are so powerful that they change the space around them. They blow gas away. They heat nebulae. They shine throughout the entire Milky Way. These extreme objects help us understand how natural laws work in their ultimate form. At such extreme conditions, the rules change. Time slows down. Space bends. Matter behaves differently. By studying these objects, we learn how the universe truly works. We see the boundaries of nature and what happens when you reach those boundaries. We cannot see the Milky Way from outside, so we rebuild it with data. We're inside it, right in the middle. We can't step outside to take a photograph, so we measure. We look at stars, at gas, at movement. And slowly, piece by piece, we build an image of of our galaxy. Radio telescopes like LOFAR and ALMA help us measure its structure. Radio telescopes listen to the Milky Way. They capture signals we cannot see. LOFAR in the Netherlands, ALMA in Chile. Together, they build an image of the invisible Milky Way. The Milky Way behind the dust. The Gaia satellite has recorded the positions of more than 1 billion stars. 1 billion stars. Gaia, a European Space Agency satellite, measures exactly where each star is, how fast it moves, how bright it is. It's the biggest star catalogue ever created. With that data, scientists can create a 3-dimensional map of our galaxy. With all that data, we can rebuild the Milky Way. We see how the spiral arms run, where the gas clouds are, how the stars move. We create a virtual Milky Way, built from real measurements, a map of our home in space. Every new measurement reveals something about our cosmic environment. Every day we learn more, a new discovery, a new measurement, a new insight. The Milky Way slowly gives up its secrets, and we listen and watch and learn. Stardust from old stars forms new material for future generations. Nothing is lost in a Milky Way. When a star dies, it spreads its material through space. That material becomes part of new clouds, new stars, new planets. The Milky Way recycles itself again and again. Exploding stars scatter elements like oxygen, carbon, and iron. Those elements didn't always exist. They were made in the hearts of stars through extreme heat and pressure. And when those stars explode, they throw those elements into space. That's how the iron in your blood formed, the carbon in your bones, the oxygen you breathe. Without this cycle, planets like Earth would not exist. In the beginning, there was only hydrogen and helium. But through billions of years of stellar lives, new elements appeared. Those elements formed planets, mountains, oceans. Without stars, no Earth, no life. The Milky Way is therefore a living system that constantly renews itself. It's not frozen, it's not dead. It breathes, it changes, it grows. Old stars die, new ones are born. It's a cycle that's been turning for billions of years and will continue for billions more. We are literally made of stardust, That's not a metaphor, but physics. You are stardust. Every atom in your body was once made in a star. That star lived, burned, and died. And now you're here, made from its remains, living, thinking, looking at the stars. From the southern hemisphere, the Milky Way is much more visible than in Europe. In Europe, we see only part of the Milky Way. But in the south, in South America, Africa, Australia, you see the heart, the center of the Milky Way with its dense collection of stars. It's a beautiful sight, brighter, fuller, more impressive. The core of the Milky Way sits in the direction of the constellation Sagittarius. When you look at Sagittarius, you're looking toward the center. There, behind all that dust and gas, sits the black hole. That's where it's busiest, hottest, most chaotic. And yet, you don't see it. It's hidden behind clouds of dust. In the constellation Cygnus, you look toward the outer edge of our galaxy. Cygnus is on the other side. When you look there, you're looking outward, toward the edge of the Milky Way. Fewer stars, more space. The suburbs of our galaxy. Because of light pollution, the Milky Way has become almost invisible in many places. In cities, you don't see it anymore. Too much light, too much illumination. The Milky Way disappears behind a haze of human light. And many people never see it, never knowing what they're missing. In truly dark places, however, it's bright and breathtaking, like a glowing river across the sky. But if you go to a dark place, far from the city, then you see it. A band of light from horizontal to horizon, like a river flowing through the sky. Soft, beautiful, full of stars.